Hi, class 10. So we have the second part of non-conventional energy. So this is comparatively much more smaller and much more easier because learning about solar and wind energy in the first half of non-conventional energy was a little more in detail. But the second half, which we'll be learning about biogas and nuclear, is comparatively smaller. But in the picture I've written biomass and not biogas. We'll be learning about the difference between biomass and biogas also, because these are two terms which are used. Even another term called biofuel is also used. And the other picture states about nuclear reactors, and you can also see nucleus, and there are electrons which are moving around the nucleus. That's also giving a bit of information about nuclear energy. So we'll be learning about nuclear energy and biogas as the third and fourth type of non-conventional energy in the part 2 of this chapter.
Biomass. Biomass energy, or bioenergy, refers to energy produced from organic matter. Biomass is primarily found in the form of living or recently living plants, as well as waste. The term feedstock is used to refer to whatever type of organic material will be used to produce energy. Different feedstocks will have different physical compositions, but generally all feedstocks include varying amounts of carbon, water, and organic volatiles. For energy production, a feedstock must be converted using one of many processes. Some common biomass conversion processes include combustion, the process where feedstock is burned in the presence of air to release heat, what happens when you start a small campfire with wood. Combustion can be used to heat steam for electricity generation as well. Gasification, the process of using heat, pressure, and partial combustion to convert feedstock into a combustible gas mixture called syngas. The syngas can then be used in place of natural gas for heating, electricity, and other uses. Pyrolysis, the process of heating feedstock at high temperatures in the absence of oxygen. Since no oxygen is present, the organic material does not combust. Instead, the chemical compounds decompose into three forms: a liquid called bio-oil, a solid called biochar, and a syngas, which we talked about earlier. Anaerobic digestion or biodigestion, a process where bacteria breaks down organic material in the absence of air to create biogas, which can be captured and burned to produce energy. The remaining byproduct is called digestate and makes a great fertilizer. Fermentation, the process of converting a plant's glucose into an alcohol called ethanol through the use of yeast. The ethanol is a liquid fuel that can be used as an automotive fuel. It is important to note that certain feedstocks are more conducive for some biomass conversion processes over others. The determination of which feedstock and process will be used is determined largely by the availability of resources and the desired end form of energy.
Okay, in that video there was quite a lot of information, but don't get too confused. It's very simple. Biomass is a very huge topic, and biogas is something which is very small within the huge topic of biomass. So what is this huge topic of biomass? What is it all about? It's pretty simple. The usage of the word feedstock. The word feedstock was used many times. What is feedstock? Either living plants or already dead plants, and any food or vegetable waste can be combined together into one term called feedstock. And what are we going to do with this feedstock? We're going to produce energy. The way in which we produce energy using this feedstock, what is feedstock? Living or dead plants or any kind of vegetable waste. So how are we going to produce energy using this feedstock? The simplest form is taking a piece of wood, burning it. You heard then the example of combustion, just like what you do in a campfire, or what do you in some places in rural regions still there are firewood which is used to burn and to use for cooking also. So it's very simple. That is also one way in which energy is produced from biomass. So combustion is one small topic in biomass. One way in which we convert the feedstock, because wood is also a part of dead living organisms or dead plant matter, or even a tree, if you cut down the wood you take from it is from a live plant matter. So converting the feedstock into energy, combustion also comes into it. Then there was many other processes like gasification, pyrolysis. So just for a second, if you pause and go back, you will find one of the many processes was anaerobic digestion, which is close towards the end of the video. That anaerobic digestion, you saw a picture of a huge chamber, and there was a gas which was coming out of the anaerobic digestion, which is feedstock, mostly dead plant matter and vegetable scraps, which are covered in a chamber and left for a particular period of time so that the methane and other gases will be produced, and there's the gas produced which is used for energy and the remaining which is called digestate. So if you pause right now and go back to that video, and towards the end of that video you will be able to see that anaerobic digestion is one among the many processes inside biomass. That anaerobic digestion process results in the end product of a particular gas, and that gas is biogas. So biogas and biomass will sound very similar, but it is actually very, very different. Biomass is the biological material derived from living organisms, while biogas is a mixture of gases produced from organic matter. Biomass is actually the combination of many, many, many different ways in which we can convert feedstock into energy. Biogas is one of the many processes, and it is actually the resultant gas, the end product. So biomass is solid state, biogas is gaseous state, biomass is composed of biological material, while biogas is composed of methane and carbon dioxide. Biomass are sources of living organisms and organisms that died recently. Even if you take a living plant and convert it into energy, you can call it biomass, but that is not biogas. Biogas is actually the end product of making sure that we keep plant matter, mostly dead plant matter and vegetable waste, for a long period of time to produce methane and other gases. And it happens with time in the absence of oxygen, and biogas is the end product. So please understand there's a huge difference between biomass and biogas. And in our syllabus, we'll be learning about biogas, but it is very, very important that you know what is biomass and how different it is from biogas. Moving into the topic that we want to learn, biogas. So in the video of biomass, there was one of the many methods which I told you before, converting feedstock into gas, into a fuel which is able to produce energy. And that fuel is in gaseous state, and that gas is biogas. And that process is called anaerobic digestion, which means decomposition of this vegetable matter in the absence of oxygen, which leads to the production of methane, hydrogen sulfide, carbon dioxide, most dominantly methane, to help us to burn fire. Biogas is a renewable energy source which is a mixture of gases produced by the breakdown of organic matter in the absence of oxygen. So that is why we use the word anaerobic digestion, because anaerobic means absence of oxygen, aerobic means presence of oxygen. Just like in previous chapters, like related to the last chapter of waste management, we learned about composting, and composting was done in two ways: aerobic and anaerobic. Aerobic was in the presence of oxygen, anaerobic was in the absence of oxygen. This process, anaerobic digestion, happens in the absence of oxygen, which means it is completely closed from the outer surface. And the final gases produced are mostly methane and carbon dioxide. Biogas can be produced from raw materials such as agricultural waste. So after we take out the produce of the crop, the remaining stalk, the leaves, any other part of the crop is called agricultural waste, manure, municipal waste, plant material, sewage, green waste, which is most probably wastage from homes, which is related to food waste, or green waste and food waste is the same, which, or vegetable waste which comes out of the kitchen. In India, biogas is also known as gobar gas. So when the final output is produced, we get a lot of gases mixed together, and this is the combination of the gases we get. So the three dominant gases we get is methane, carbon dioxide, and nitrogen. But in some cases, the three dominant gases, the third dominant gas would be hydrogen sulfide instead of nitrogen. That depends from place to place and the kind of raw material or vegetable material or waste we put into the plant, which means we put it to the digestion system, anaerobic digestion system. Depending upon that, the presence of hydrogen sulfide and nitrogen would vary. But most commonly, methane and carbon dioxide will dominate, and even among the two, methane will be the most dominating gas which will be produced from biogas. So, what is the most dominating gas produced from biogas? It's methane. You should clearly know that methane is the gas which is helping us to light the stove or cause the combustion and create fire, because carbon dioxide is something which is in fire extinguishers. It won't allow us to burn fire. It is something which is helping us to extinguish fire. So it's actually doesn't make any sense when we say biogas produces carbon dioxide which helps us to burn fire. No, it produces methane dominantly, and along with methane there's a little bit of carbon dioxide, but most dominantly it's methane, and that is why we are able to produce fire. So this is how the system works. You have a mixing tank, which is probably the place where we'll be dumping the waste, and an inlet pipe. In the inlet pipe, straight away goes to the digester tank, which is the place where it will stay. The waste, plant waste, or even if it's cow dung or whatever, if it stays there for a long period of time, slowly what happens is that that place starts to produce methane and the other gases. After some time, the gas straight away goes to the gas holder, and there's the gas control valve. Whenever we want to switch it on, the gas control valve will allow the gas to go to the gas stove. When we switch off the valve, it doesn't go to the gas stove. Just like how you have a valve in your LPG cylinder. When you switch off the valve, even though you light your gas stove, it doesn't fire because the valve is locked. Because the gas cylinder has to allow the gas to pass through the pipe to the gas stove. Same way, this gas control valve is connecting the gas holder. The gas holder acts like your LPG cylinder here, and the valve is the same function. And when you open the valve, it flows to the gas stove, and then you light it, you get fire. Okay, the remaining waste will go to the outlet pipe, and from the outlet pipe, you have the place where the remaining solid waste comes out, which is also called digestate and which can be used for manure. So we'll split it out into smaller processes. Number one, the shed is the region which is also a chamber which is open to the surface, and it's the space into which vegetable waste or animal waste such as cow dung is dumped. You can clearly see that in the picture. So once the shed gets filled, there's a passageway which is locking or blocked. The passageway will be lifted, and from the shed, that vegetable waste or animal waste will be dumped, or it will flow into the digester tank. Digester tank is the biggest tank in the whole of biogas, and that is the place where it will stay for a long period of time and the fermentation process will happen. A passageway connects the shed to the digester tank. This is below the surface and totally blocked from any presence of oxygen from the surface. So that's a very important point. Shed is connected to oxygen, digester tank is not connected to oxygen. It's here that the waste stays for a long period of time and starts fermenting and producing biogas. With time, methane, carbon dioxide, and hydrogen sulfide produce. So after some time, the digester tank gets filled, the shed gets empty, and with a long period of time, you can see green bubbles popping up, and that is the methane gas along with a little bit of hydrogen sulfide and carbon dioxide. But mostly it is going to be methane which is dominant. Since gas is lighter, all of us know that gas is lighter than water, gas is lighter than any solid, it will rise up. It settles above the solid waste and the solid waste will be below. So you can see the green bubbles are rising up. It will rise up to a particular point that the total top portion of the digester tank will be filled with the gas. As the quantity of gas produced increases, it moves through the next pipe from the digester tank into the biogas storage tank. In the first slide of biogas, you would have seen the big tank. That is the same tank here, which is showed in an illustrative diagram. So this gas produced, which is a renewable natural gas, which is cleaned, compressed, and sent into the CHP tank. CHP tank is another other than the biogas storage tank, and it starts flowing into the biogas storage tank. And it will take quite a while in the huge biogas storage tank. It's almost like the LPG cylinder. That huge storage tank should be filled with biogas. So it will take a long time. It took a long time for the digester tank to be filled. It took a long time for the green bubbles to come up. It took a much more time for the green bubbles to fill in the top portion, and then it moves into the storage tank. And now also it will take more time for the storage tank to be Once the storage tank is filled, which is step 5, with time the biogas storage tank gets filled, and then when it's filled, it has an outlet pipe. An outlet pipe has a valve, and when the valve is unlocked, which is the pipe on the right side, it will flow through the pipe straight to the output, which is your gas stove, where you can light it and use it for cooking. The remaining solid waste in the digester tank, so there's gas produced in the digester tank which goes to the biogas storage tank and gets filled there, and from there goes to the output to the gas stove. And still there's the solid waste which has not yet been converted or which is remaining even after the conversion of biogas. That solid waste is called digestate. You should remember the term, it's very important, digestate. So because it's heavy, if you put a hole at the bottom of the digester tank, because of gravity, it flows out as a slurry or waste, which will be a sticky material, and you make it dry, it converts into compost, or it can be used as a biofertilizer for crops and agriculture. So that everything which is produced, either it's the gaseous thing which is produced or the solid waste, it has been removed out of the digester tank and now it's empty again, ready for the next set of production of biogas. Even though it looks really good, it still has a lot of advantages and disadvantages. We'll go with the advantages to begin with. And advantages are clean and non-polluting form of energy, very simple, low cost of production compared to all the other gases like solar or wind. It's very cheap to produce biogas. Natural waste like dung and vegetable matter are disposed properly if we have a biogas, and it will reduce the landfills. Otherwise, everywhere there will be landfills and piles of degradable waste. No storage problem as gas produced is directly sent to destination. Like in a nuclear reactor or in a place where other energy is produced, you need a place to store the energy for a long period of time. Here, even if it's stored in a big biogas tank, it will be used within 1 or 2 days. It's not stored for a long period of time. Reduces strain for collecting firewood. You can see the picture where every single rural family has this difficulty of going every day and collecting firewood. That strain is reduced. That's a big advantage. The byproduct can be used for manure, which we saw in digestate. And the last point is very important. It's a double benefit for the farmers. The first picture you can clearly see that it's a farming community. They have plants, they have crops, they have animals or cattle, and plant waste. At the same time, the um, cattle's excreta both can be used for the production of biogas, and it can be used for lighting their homes. It can be used for fuel. The digestate can also be used for manure to improve the quality of crops. So if you look at it from a farmer's perspective, it is a huge double benefit. So their crops grow well, the cattle is healthy, at the same time they get easy input of raw material from the cattle and the crops, and they're able to give it back to the crops and the environment as well. But what about the disadvantages? More doable in rural areas where there's an abundance of bio waste. There's not an abundance of bio waste if you go to a city like Mumbai or Delhi compared to a rural place. So that's a very big disadvantage. Large areas are needed for installment. So there's a difference. It's not large amount of money that they're talking about. Cost of production is always an advantage, is less. But area for production, even if it's a rural area, you need a large area to construct that huge tank and connecting pipes of inlet and outlet. So it takes a large area. And you can never imagine having such a large area in a city to dig a huge hole and construct a big tank. So that's a big disadvantage. If a leakage occurs, the sludge will pollute the nearby water bodies, which is a huge disadvantage. The digestate or the remaining sludge, even though it's a good biofertilizer, if it moves into any underground water body, because it's already underground, storage tank is already underground. If it breaks open, it goes and mixes with underground water bodies, it will pollute it significantly. Cannot be done in colder regions because the optimum temperature required for digestion to take place is 37 or 35 degrees centigrade. So more than 30 degrees centigrade is a mandate, is required for this to happen. And if it's a place which is below that, it's very going to be very difficult. Not highly suitable for city life due to the maintenance difficulties, as we mentioned earlier. There's not much space there. There's not enough abundance of bio waste. The raw material of vegetable waste or animal waste, it's not much in cities. So in many ways, it's not possible to construct a biogas plant in a city compared to a rural place. Moving into the next one, nuclear. Nuclear energy originates from splitting of uranium atoms, a process called fission. This generates heat to produce steam. The steam is used by a turbine generator to generate electricity. The steam actually rotates the generator, rotates the turbine, and the turbine rotates the generator, and the generator will produce electricity. Because nuclear power plants do not burn fuel, they do not produce greenhouse emissions. So this is the system and this is the generation process. Let's see how it works. We have 1, 2, 3, 4, 5 uh, important phases it goes through, and each phase has an important point to tell. Number one, you can see three vertical rods lifting up. It's a nuclear in the nuclear reactor fuel rods. So these three are the fuel rods of uranium pellets are placed in water. So these three rods has a lot of uranium pellets. So nuclear energy is mostly about splitting of atoms or combining of atoms. Mostly it is done with splitting of atoms, which is fission. Combining of atoms is fusion. So this splitting of atoms need to take place at a very sophisticated and highly scientific system or an environment where there's very minimal chances of an accident taking place, because it is going to release so much of energy. This is the same energy which was released when the atom bombs of Hiroshima and Nagasaki were dropped in Japan by America, I think, during the Second World War. The same fission reaction. And what was the result? The huge city got completely destroyed. So it's not a small thing, it's a very, very big, dangerous activity which is taking place. So it might look very small, but it's a huge, dangerous activity. And in the nuclear reactor, in the first phase, what happens is that there are three fuel rods, and mostly it will be three, sometimes it will be five, filled with uranium pellets. It can be uranium, it can be thorium, it can be rubidium, any radioactive element. Most commonly, it is uranium which is used. So pellets are nothing but small tablets or size of bullets, which will be called pellets, are placed in water. So the fuel rods has uranium pellets, it's in water. Number two, inside these fuel rods, which are already in water and has uranium pellets, this uranium atom starts splitting because of the increase in temperature of the water. We start increasing the temperature of water, and this splits the uranium atoms. The energy heats the water again. So initially the water was just a little bit warm, then it splits the atom, and then the splitting of the atom releases so much energy which makes the water so hot and boil. When the water boils, it obviously will create steam. The steam moves through the turbine, and the turbine will start to move or to rotate. So it's just like a wind. When you blow it on the blades of a fan, it starts moving. Or when you have a toy fan in your hand and you start blowing it at it, it starts moving. The blades start rotating. The same way steam also acts like wind. When it flows into the blades of a turbine, it starts rotating, and this rotation turns the generator and creates electricity. A steam cools back into the water, which can be used over again. So once the steam rotates the turbine, there's still a lot of steam after the turbine is rotating. You can see that between 3 and 4 in the picture, you can see that the arrow mark of steam moving towards the right, then that's the turbine, and after that there's an arrow mark moving downwards, which is actually moving to number 5, which is the cooling tower. The steam cools back into water, which can be used over again. The water is again sent into the nuclear reactor number 1, where the fuel rods are kept into uranium pellets in water. So they're not wasting the water which is converted into steam. It's again cooled down and again sent back to reactor number 1. And it is again used in a place where when the uranium atoms split, energy is released. When energy is released, it produces heat. When heat is produced, it boils the water. When water is boiled, it creates steam. When steam it creates, it rotates the turbine, and this turbine rotates the generator, switches on the generator. The generator produces electricity. The electricity is sent to the nearby towers. So this is the whole system of nuclear energy power generation. And the most important thing needed is water to produce steam, and more important than water is radioactive elements, and the atoms of radioactive elements most commonly used is uranium.
Nuclear energy. Nuclear energy is the energy held in the nucleus of an atom. It can be obtained by two types of reactions, fission and fusion. Nuclear fission produces energy through the splitting of atoms, which releases heat energy that can be harnessed to produce electricity. The fuel most commonly used for nuclear fission is uranium. However, other elements such as plutonium and thorium can also be used. All of today's operating nuclear plants use nuclear fission to generate electricity. The second type of nuclear energy is nuclear fusion, the same process that powers our sun. Fusion is a nuclear reaction in which atomic nuclei collide at a high speed and join to form a new type of atomic nucleus. During this process, matter is not conserved because some of the matter of the fusing nuclei is converted to photons, which produces energy. Fusion power offers the prospect of an almost inexhaustible source of energy. However, creating the conditions for nuclear fusion presents a potentially insurmountable scientific and engineering challenge. A recent experiment has shown that nuclear fusion can be achieved. However, it has not yet been successfully demonstrated on a commercial scale. Today, nuclear power plants account for 11% of global electricity generation, with about 80% of that installed capacity being in OECD countries. All of this capacity is nuclear fission. Nuclear energy, through fission, can release 1 million times more energy per atom than fossil fuels. Nuclear plants have large power generating capacity and low operating costs, making it ideal for baseload generation. Because of its large scale and centralized nature, it can easily be integrated into electricity grids, requiring few changes to existing infrastructure. However, upfront capital costs are intensive and present financial risks to investors given the long time frames power plants must operate to recover these costs. Nuclear energy does not emit greenhouse gas emissions. For this reason, it is often seen as a substitute for fossil fuel electricity and a solution for mitigating climate change. However, nuclear power holds a wide variety of environmental and health issues. The largest concern is the generation of radioactive wastes such as uranium mill tailings, spent reactor fuel, and other radioactive wastes. Some of these materials can remain radioactive and hazardous to human health and the environment for thousands of years. Several nuclear accidents in recent history have negatively impacted the environment and surrounding communities, making nuclear power a controversial topic for the general public.
In that video, there was a lot of information and it ended in such a way that it still remains to be a controversial topic, even though we see a lot of nuclear reactors releasing a lot of gases, but it's not actually gases, but it's steam which is coming out because the water boils and it's actually steam that's coming out. So there's no air pollution that takes place, there's no water pollution that takes place unless and otherwise steam is directly let into water bodies, which happens in many places, which results in thermal pollution, which is the increase in water temperature. But in many ways, nuclear energy is highly advantageous because you just need a little bit of uranium or thorium or plutonium or any of the radioactive elements. A little bit of it, probably just few atoms you need. And you're able to produce so much of energy, 10,000 times than fossil fuels. Just imagine how much energy that would be. So if we are able to do it in a very productive, proper, secure way, it will definitely be a big advantage in the coming years. So there are advantages and there are disadvantages. We'll just move one by one, going through the advantages and disadvantages. The advantages are is that clean and renewable. So it's just a common advantage with all the non-renewable types of energy. And there's another advantages which are specific to nuclear. So while I was teaching about the advantage and disadvantage in the previous chapter, previous half of this chapter, I was saying please write specific advantages for that particular energy. Like for solar, write specific advantages for solar. For wind, specific advantage of wind. Same way, in nuclear, there are specific advantages which are from number two. Production of energy in enormous in a single fission or fusion reaction. So you don't have to do it multiple times or many times. In one single fusion or one single fission, there's so much energy produced. The raw material required. What is the raw material required? Just one single atom. One single atom can produce you so much energy. It must be a radioactive element atom, but still the amount of raw material required is less. So even if you have very less uranium, you just need one atom. So obviously the raw material you have is in abundance. Because the amount of raw material you use is very little, the raw material you have will always be abundant. The cost of raw material used is 20% of the cost of energy produced out of it. So if you spend 20 rupees, which means The remaining 80 times or 80 percentage is what you're gonna produce out of it, which means if you spend 20 rupees, the remaining 80% you will be producing out of it, which is quite a lot, which is more than 200 or more than 250 rupees that you'll be producing out of it. So the ratio of the amount of money invested to the amount of money gained is so huge. Large storage tanks can hold high volume of nuclear energy. So you can see the nuclear reactor tanks, which are not very small, it's so huge. It can hold high amount of energy and high volume of energy, which is also a big advantage. Safe disposal of radioactive waste is difficult. That's one big disadvantage. Presence of radioactive elements are uniformly and abundant everywhere. It doesn't go away very easily. It's present. This poster, you would have seen it very often. It's a famous documentary which has come in HBO, which has come in Hotstar, which has come in other English channels as well. And it's a famous disaster which happened in 1986 in Ukraine in a place called Chernobyl. And it's considered as one of the most dangerous and the most intense, if not the most intense industrial accident. And it happened in a nuclear reactor, which was in Chernobyl in Ukraine. So large scale accidents can be catastrophic. Even if you go to Chernobyl today, there's not much people who are living there, and the life there is very bleak because there are still traces of radioactive elements which happened in 1986. So it's almost like 40 years, 44 years. Still, there is the influence of radioactive damage still there. Cost of buildings and safety requirements are very high. That's a very big disadvantage. It can be properly maintained, but the requirement of safety is 10 times or 100 times more in nuclear compared to any other type of energy. Local thermal pollution, when steam is released through the gases or steam is released in water. There was a question I asked recently in the previous exams about a kind of water pollution which happens when there's an increase in temperature, and when there's an increase in temperature there's a decrease in oxygen, and that kills marine life. And most of you tried to answer it differently, but very few got it right, which is actually the answer was thermal pollution, and the reason for it was nuclear reactor. So these are the advantages and disadvantages. In the picture you can see the red zone in the picture above is actually the region where you have a lot of nuclear reactors effluents, which is steam and warm water coming out. So if it's directly sent into the water body, it's going to definitely reduce the amount of oxygen and increase the temperature and kill all the marine organisms. This is a very interesting video. I'm going to end it with this. We have learned about conventional source of energy previously, which was coal, petrol, and biogas, and natural gas. And then we learned about non-conventional. Four types of energy we learned: solar, wind, biogas, and we also learned about biomass and about nuclear. But here are some very new and interesting innovations that has happened in the recent past, which literally blew my mind away. And it was so amazing to see the different ideas of people coming up, and we were able to. I hope we are able to witness this in our country as well. So I hope this inspires you also to create different ideas to make sure that we are not harming the environment, but actually making something which is better for the environment by using the resources properly, by using sunlight or wind or water properly and able to produce energy. Energy is something that we need. We cannot live without energy. Energy to light our homes or to cook or to ride our vehicles. We need energy. But how are we producing it? That's very important. So we have learned so much about the conventional types of coal, petrol, and the non-conventional types of sun and air and water. But how are we going to use our brains to find out new inventions like what is here today? So here are some 10 or 12 inventions which are so amazing, so different, so unique, where we don't harm the environment at all, but at the same time use what the environment gives us and what the earth is giving us to the best way possible to produce energy. I hope you enjoy it.